So in this problem, we need to list the set of all integers whose cube is an even integer. Let us begin. So here we will consider the set to be represented by the letter A in uppercase, and we'll have to list out all the elements within the parentheses. We'll come back to that in a moment. So let's say we have the set of integers. Now when we consider the set of integers, we have to consider all the negative values. So let's say we take -4, -3, -2, -1. We have 0, and then we also have the positive values as well. Now from this set of integer values, we'll pick up only those integers values such that when we take the cube of those integers, it gives us an even integer. For instance, let's say if we consider x, so let's say x is an element of the set A, which is an integer, such that if we consider x to be equals to -4, and if we cube it, so if we cube x, then we're going to have -4 cube, which is going to give us -64, and this clearly is an even integer. -64 is an even integer. Then if we consider x to be equals to -3, then cubing x gives us -3 cube, so this will be equals to -27, which is not an even integer, so that's an odd integer. So not an even integer, so we are not going to consider this particular value of x, so we're going to reject this value. So if we take x equals to -2, so that means we have x cube equals to -8, which is an even integer. So here we can observe that if x is an even integer, then its cube is also an even integer. So what we'll do, we're going to consider only the even integers. So that means the set A is going to contain the elements -4, -2. So we can also consider 0 because 0 is an even integer. Then we have 2, 4 on the rest of the terms. And if we want to express the same set in the set builder form, then we can express it as A is the set containing the elements x such that x is equals to 2 times n. That means x is an even number and n belongs to the set of integers. So this is how we can express the set of all integers such that whose cube is an even integer.